All right, so in this section, we're going to be talking about some graphing techniques. Now, this is going to be a two-part video. The first part, we're going to start with vertical and horizontal shifts, and then we will go into doing vertical and horizontal compressions and stretches, and then in the second video, and we will also talk about reflections about the X and Y axis. Okay. So again, all of these are just kind of graphing techniques that will help us whenever we're actually interpreting these graphs. Okay, so let's take a look at this first example. Actually, there's a rule that I actually forgot to put on here. And that is the rule for vertical and horizontal shifts. Okay, so if I give you a number k, so I'm going to kind of try to phrase it the way that I phrase these definitions down here. A function is a vertical shift if you're adding or subtracting to the outside of the function. Okay, so if I'm looking at maybe this example down here, f of x is equal to x squared. If I'm adding it to the outside, so this would be what I consider adding to the outside. If it's in parentheses, it's adding to the x value. Okay, but it's a vertical shift up if you have the function, if you start with the function y equals f of x, then it's a vertical shift up if you have y equals f of x plus k. Okay, so it's a shift up if we're adding k to the end of the function. Okay, it's a shift down if we start with this function y equals f of x, then it becomes a shift down if we have y equals f of x minus k. Okay? So that's kind of the key that we're looking for here. So what I'm going to be looking for in these examples is for you to always kind of take a look at what the parent function, what the function looks like with no transformations done to it. Okay? So we're going to eventually be graphing this function here. Okay? But what I want you to be able to do is take away all of the transformations and see what we're left with. So if I took away the transformation here, which is minus 4, all we're left with is this original function, x squared. Okay, so I want you to be able to recognize what the shape of those graphs look like. Okay, so what this graph does is it's a shift down 4 units. So what I'm going to do is if I have my original function, so down 4, okay, I'm going to pick a few points. Typically, I just pick the ones in the middle, and I'm going to shift each of those points down 4 units. So I'm going to go down 4, put a dot, down 4, put a dot, down 4, put a dot, and we can keep doing this with each of our points until we have our overall shape. And then I'm going to connect the dots. Okay, so I've got my graph here, and that's all you're having to do. So it's a shift down 4 units. And again, this is where knowing the general shape of your function really comes in handy. It's going to save you a lot of time whenever it comes to graphing. All right, now we're going to start talking about a horizontal shift. Okay, so a graph is horizontally shifted to the right if the function is subtracting h. Okay, so if we start with our original function f of x and we subtract h, then the function is going to be shifted to the right h units. Okay, the function will be shifted to the left h units if we're adding h to the function. Okay, so it's shifted to the left h units if we're adding h to the function. Okay, so using this information, I'm going to take a look at this graph, and I'm going to graph it using vertical and horizontal shifts. This is the last thing we're going to do in this video. This is, again, a two-part video that we're going to talk about, okay? So what I want you to do every single time is I want you to kind of imagine what the parent graph of this is. I'm not always going to give you what the graph looks like or what the original graph looks like, okay? So The way we're going to do that is I'm going to simply mark the transformations out, so the +3 and the -5, and what we're left with is f of x is equal to x squared. Okay, so this is the parent function. This is the function that we're going to be transforming. Okay, so now let's go ahead and take a look at what these transformations look like. Okay, on the inside here, this is x plus 3. Okay, so taking a look at our horizontal shift, so if it's in parentheses, it's a horizontal shift. Okay, and this is addition, so it's going to be a shift left however many units. So the green part is a shift left 3 units. Okay, so let's go ahead and plot those points. So again, I'm just going to pick a few points. So maybe here, here, and here. I'm going to shift them to the left 3 units. And we have our new graph over here. So this would be the green underlined part. Okay. However, we do have this an end. Okay, so now we're subtracting 5 from the outside. Okay, so remember, if it's on the outside of the parentheses, it's a vertical shift. Okay, so this is a vertical shift down 5 units. Okay, and we're not shifting the black line now, we're shifting the green line. So these are kind of building on top of each other. Okay, so I'm going to take each of these points in the green line that I just graphed, I'm going to shift them down 5 units. So I've got a point here, a point here, and a point here. And again, I'm just going to trace through these graphs. Okay, and there we have it. If I were to erase this kind of intermittent step, we have our new function. So again, each of these points needed to be shifted to the left 3 and down 5. And that's all we're doing there. All right, so this